Hello, everybody. So today we are going to be learning about the periodic trend of the atomic radius. So in your Edmodo, go to the post that says atomic radius. We have the link for the reading. The practice questions had some pictures that I couldn't necessarily copy and paste. So as soon as I can scan that, that's going to be on there too. So let's take a look at the periodic trend of atomic radius. So first of all, we need to understand what a periodic trend is. So a periodic trend is going to be different characteristics of atoms and how they behave as we move about the periodic table. So as we move from left to right, or as we move from top to bottom in respect to the periodic table. Okay, so right now we're looking at how the atomic radius changes. First of all, we're going to look at how they measure the atomic radius. So the size of an atom is going to be defined by the edge of its orbital, but orbital boundaries are fuzzy and are variable under different conditions. Okay, so to get a standard measurement of atomic radii, the distance between the nuclei of two identical atoms bonded together is measured. So if you were to take two hydrogen atoms and bond them together as an H2 atom, as an H2 molecule, you would measure the atomic radii, which would be the distance between these two nuclei, these two centers of these atoms. All right, so the atomic radius is defined as 1/2 the distance between the nuclei of identical atoms that are bonded together. So we use this measurement between these two nuclei, we divide it by 2, that is our atomic radius. All right, so the units for atomic radii are picometers. So it's very, very tiny because it is 10 to the negative 12th meters. So the distance, for example, the distance between two identical hydrogen atoms is 74 picometers. So remember, we want to use half that distance when we're talking about the atomic radius. So the atomic radius is going to be 74 divided by 2, which is 37 picometers. Now, this is a good image to have when you're thinking about atomic radius, and these are the general trends. So the atomic radius increases from right to left across the periodic table. If you're going from left to right, the atomic radius is going to decrease. Okay, and we'll get to why that is in just a little bit. So if you're moving down a group from top to bottom, the atomic radius increases. All right, now let's look at this. There are a few exceptions. There are a few exceptions. So one exception is the oxygen radius is going to be a little bit greater than the nitrogen radius. So when we're going across a period, we are adding protons to the nucleus as electrons are being added to the same principal energy level. Okay, so the electrons are going to be pulled in closer to the nucleus because they are attracted to this positive charge and they're all filling the same energy level. All right, so because of this increased force of attraction between the protons and electrons, the size of the atoms is going to decrease because the protons are pulling in the electrons and as a result making the atom smaller. So this effect gets to be less as you move from left to right, as you move further to the right in a period, because there are electron-electron repulsions that are taking effect. So we said that with a group, the atomic radius increases from top to bottom. Okay, so we are increasing atomic number as we go down a group. So, and we are also increasing the number of electrons, but there's an increase in the number of occupied principal energy levels. So as we go down a group, we are actually filling higher and higher energy levels. All right, so higher principal energy levels consist of orbitals which are larger in size than the orbitals from lower energy levels. Okay, so the effect of these greater number of principal energy levels outweighs the increase in nuclear charge. Okay, so it's going to outweigh that effect from the attraction of the protons and the electrons. So I hope that makes sense. Make sure you finish your questions, turn them in to me.